Okay, 3.7, determinants and Kramer's rule. This is a little more complicated, takes a little longer, so you're only going to have to do a few. And what we're really shooting towards is how do we solve equations with lots of variables? I go back to the idea of how do we get a weather model? How do they know where that tornado is going to go? How do they know where that storm is going to go, or how much rain we're going to get, or what the winds are going to be, and all that? There's a lot of variables that go into that. So matrices are pretty powerful in allowing us to organize a lot of variables and then put them together. And again, with technology, we have systems to do this a lot easier, but there's sort of these old tools that could be used to do this. So I consider this enrichment, and again, it's almost like puzzles, and it's about being persistent and trying to kind of find the joy in sort of figuring something out. So this could be kind of long, so bear with me, stay patient, and be persistent. All right, let's see how this works. So we're starting with the idea of a determinant, and the reason is we'll need to use this later. The determinant of matrix A is written like this. They look like absolute value symbols, but they're not. And then if we say the determinant of some 2 by 2 matrix, I put the determinant symbols. And the way it works is that I do A times D and I subtract B times C. So the determinant is actually a single value. So how would I define the determinant of this? It would be 5 times 1 minus 4 times 3. So 5 minus 12 is negative 7. So the determinant of this 2 by 2 matrix is negative 7. Now if we have a 3 by 3 matrix, things get a little more complicated because I got to go like this, and then I got to go like this. So in order for there to be something there, I've got to repeat these columns. So I need to write 2, 4, well, let me do it, sorry. Yeah, let me do it. 2, 4, 3, and then I've got to write that column again. 1, negative 1, 1, negative 4. So now I do this, plus this, plus this, and then I'm going to subtract this, plus this, plus this. So it looks like this. 2 times 1 times negative 2, plus negative 1 times 0 times 3, plus the third diagonal, negative 3 times 4 times negative 4. So that's kind of just like my A times D, except I have 1, 2, 3 of them. So that's my beginning. So I'm going to take all of that, and then I'm going to subtract all these guys, all these diagonals. So 3 times 1 times negative 3 plus negative 4 times 0 times 2 plus negative 2 times 4 times negative 1. So these multiplied plus these multiplied plus these multiplied minus these multiplied plus these multiplied plus these multiplied. So somewhere I did all this and it works out to be 44 minus a negative 1. So the determinant of that matrix is 45. So a little tedious, but not too bad. And again, we can do these with our calculators, but for now, practice doing them by hand. Now, what do we use the determinant for? A couple things. First being finding the area of a triangle given its coordinates. The second is going to be solving a system of equations. So if I want to find the area of a triangle and I have a set of coordinates x1, y1, x2, y2, and x3, y3, the area of that triangle is 1/2 times the determinant x1, y1, and then the number 1, x2, y2, and then the number 1, x3, y3, and then the number 1. So again, this means determinant. So suppose I had a set of coordinates that looked like this. The first coordinate was -3, 1. And again, you need that third one. The second coordinate was 2, 0. The third coordinate was 3, -1. And again, since it's a triple, I got to bring these guys over. -3, 2, and 3, and 1, 0, -1. And then I got to do this, plus this, plus this. Oh, I put a cube there. Plus or minus, because sometimes the determinant can come out negative. So if the determinant comes out negative, then you'd want to negative that because area has to be positive. So think about what you have. -3 times 0 times 1 is 0. Plus 1 times 1 times 3 is 3. So 0 plus 3 is 3. And then plus -2. 3 times 0 times 1. Yep. So that's, I just better do it. 0 plus 3 minus 2 minus 0 plus 3 plus 2. So it's plus or minus 1/2 1 minus 5. And so since it's going to be 1/2 of -4 would be -2, so that answer is 2. The area of the triangle is 2. So you just have to take your time and do the math correctly. I may or may not have made a mistake, but and you know, how else could you do that? You could set up a bunch of right triangles and find their areas. Again, this sort of allows us to sort of plug things into an algorithm and solve using the algorithm. I think I'm going to stop there because it's long to load these. So the next video will show you how to use determinants and Kramer's rule to solve a system of equations.